Hey everyone, welcome to this explainer. We are jumping right in today to demystify searching algorithms and two-dimensional arrays in C to get you fully prepped for your upcoming assignments and exams. Let's get started.
Here is our roadmap for today. 1. Searching arrays linear method. 2. Fast searching with binary search. 3. Multidimensional arrays overview. 4. Initializing 2D arrays properly. 5. Manipulating 2D array data. And finally, 6. Final recap and key patterns.
All right, section 1, searching arrays linear method. Imagine looking for a specific playing card in a messy deck. You just check every single item until you spot the one you want. Well, that's exactly what a linear search is. The function simply steps through an array, starting from the very first index, evaluating each and every element against our search key. It takes the array, the key we're looking for, and the size of the array, and just runs a simple for loop from index 0 straight to the end. It's incredibly straightforward. There's literally zero complex logic required here. So if it actually finds a match, boom, it immediately returns the subscript, the index where the key was found. But what if it doesn't? If it checks every single element and still comes up empty-handed, it returns a -1, which is the standard programming convention for key not found. Now, on average, this means your program is going to compare the key with about half the elements of the array. That's perfectly fine for small or completely unsorted datasets, but as you can probably guess, it's terribly inefficient for really large ones.
Moving right along to section 2, fast searching with binary search.
Now, if your array happens to be sorted, meaning everything is perfectly organized in ascending or descending order, we can totally ditch that slow brute force approach. Enter binary search. It's a total game changer. While linear search plods along one by one, binary search works by jumping straight to the middle and immediately eliminating half of all possibilities. Think of it like looking for a word in a physical dictionary. You don't start at page 1 and read every word, right? No, you open to the middle. If your word comes alphabetically before that page, you ignore the entire second half of the book and chop the first half in the middle again. It is a wildly elegant solution. In C, we pull this off by defining a low subscript and a high subscript. Inside a while loop, we calculate the middle index. If the number we're searching for is less than that middle element, well, we just set our new high subscript to middle -1. We're effectively telling the computer, hey, only search the first half. Conversely, if it's greater, we adjust the low subscript to middle +1 to search the second half. And if they're exactly equal, boom, we found it, and we just returned that middle index. This really puts the raw power of binary search into perspective. Searching an array of over 1 million elements, that takes a maximum of just 20 comparisons. But get this, jumping to a massive array of 1 billion elements takes a max of only 30 comparisons. No way, right? It's true, because the maximum number of comparisons is just the first power of 2 greater than the number of elements in the array. For 1 billion elements, 2 to the power of 30 is just over 1 billion, so 30 comparisons max. It's a staggering performance upgrade. Let's shift gears a bit. Section 3, multidimensional arrays overview. To build a solid mental model for 2D arrays, just picture a 3x4 grid, a perfect little table. Notice how every single element here needs 2 subscripts to be identified, not just 1. So all the elements sitting up in row 0 are accessed as A00, A01, and so on. You absolutely need to memorize this exact convention for your exams. It is always row first, column second. Row, column. When this is actually stored in the computer's memory, which, by the way, is essentially just flat, the compiler stores all the elements of row 0 back to back, right before row 1 starts. But the beauty is, as a programmer, you get to interact with it conceptually as this neat two-dimensional table. Next up, section 4, initializing 2D arrays properly. When you're setting these arrays up, you group the values by row inside nested braces. Take a look at the first example. The first set of inner braces handles row 0 with 1, 2, 3, and the second set handles row 1 with 4, 5, 6. And here's a super helpful tip for your assignments. If you don't provide enough initializers for a row, C will just automatically default those unassigned elements to 0. It's a nice little built-in safety net. Okay, I really want to spotlight a huge trap here. This will literally eat up hours of your debugging time if you're not careful. Never, ever use a comma between your subscripts. If you write A bracket X comma Y bracket, that is a massive logic error. The wild thing is C won't necessarily stop you with a syntax error. It'll just treat the comma as an operator, use the last value, and your program will act super strange by accessing a completely wrong memory location. Always use independent brackets for each subscript.
All right, Section 5, Manipulating 2D Array Data.
The absolute ultimate tool for navigating a 2D array is the nested for loop. It's like a superpower. The way it works is by handling the data one row at a time. The outer for loop dictates the row, and the inner for loop dictates the column. It holds the row constant at 0, totally iterates through every single column in that row to add the values up, and then the outer loop increments the row to 1. To make absolutely sure this logic is crystal clear for your assignments, let's step right through it. Step 1, the outer loop locks the row in place. Step 2, the inner loop sweeps left to right across all the columns. Step 3, the inner loop finishes its cycle. And finally, Step 4, the outer loop shifts down to the next row, and the whole shebang starts over, row by row, column by column.
Let's apply this to a real-world example. Imagine an array where the rows represent individual students and the columns represent their specific exam grades over a semester. So, looking at student 0, they might have grades of 77, 68, 86, and 73.
So what if we want to find the absolute lowest grade in the entire class? We use those trusty nested loops. The outer loop cycles through the students, the rows, while the inner loop compares each test grade against a low-grade variable. Now, a quick aside. You have to initialize that low grade to a high possible value, like 100, for this to work right. Every time it encounters a grade smaller than low grade, it updates it to that new, smaller value. By the time both loops finish, you are absolutely guaranteed to have the lowest number stored right there.
And that brings us to Section 6, Final Recap and Key Patterns. Let's rapid fire the biggest takeaways. Linear search, that's your brute force method checking every element. Binary search is incredibly fast but absolutely requires sorted data, and its max comparisons are always tied to powers of 2. For 2D arrays, always remember the row then column bracket convention, completely banish the comma operator from your array calls, and make the nested for loop your best friend. Master these and you will totally crush arrays on your upcoming tests.
I'll leave you with that provocative thought to spark your curiosity. A digital image on your screen is essentially just a giant 2D array of pixel color values. How would you write a nested loop to turn an entire image grayscale? Think about it. Thanks for tuning into this explainer, and keep exploring these concepts. You are well on your way to mastering C programming.